All right, guys, so today we're going to go over dimensional analysis, which is also known as the factor label method. So this is a way of converting from one unit to another. It's kind of our universal way of communicating in chemistry. So there are a couple of key things that we need to know in order to understand how to set up dimensional analysis or the factor label method. The first thing is algebra. We have to realize that if something is in the numerator and something is in the denominator, it will cancel out. It doesn't matter if that something is a variable, if that something is a number, or if that something is a unit. So that's the first key to this. The second key is that we are going to be using what we call equivalents. So for example, we know that 12 inches and 1 foot are equal amounts of distance. So 1 foot is equal to 12 inches. We are going to take those equivalents and we are going to write them as a factor conversion or as a unit conversion. When we do that, we are going to put it in fraction form. So I'm going to write it 1 foot on the top and 12 inches on the bottom. The key is that the top and the bottom of the fraction should each be equivalent to each other in terms of distance. So not in terms of numbers, but focus on the distance. 1 foot and 12 inches are the same. So in terms of distance, this is equivalent to 1. Now I could also write this as 12 inches over 1 foot. Again, even though I have it written the opposite way, the fraction in terms of distance is equivalent to 1. So the key to this is making sure, A, that we understand that something in the numerator and the denominator will cancel out, and second, that we make sure that the top and the bottom of the fraction are always equivalent in terms of distance, time, mass, whatever it is that we are converting. All right, so let's do our first problem here. If someone is 150 million seconds old, I want to know what is their age in years. So when you first approach a problem, the key is to figure out what unit are you starting with and what unit are you ending with. So in this case, my end goal is to figure out their age in years. I am starting with their age in seconds. It's an equivalent amount of time. I'm just trying to convert from one to the other. So I am going to come up with a pathway. You can do this in your head as you get better at this, or at first, it's a good idea to write it down so that you know exactly what steps you're going to take along the way. I'm starting in seconds, and I am trying to get all the way to years. So I'm going to come up with a plan in order to get from seconds to years. I have no idea how many seconds are in a year, but I do know that I can easily get from seconds to minutes. Once I'm in minutes, I can change those minutes into hours. I can change my hours into days, and I can change my days into years. So I want to figure out a pathway. Next thing I need to do is determine what are the equivalent values for those. So in terms of seconds and minutes, I know that 60 seconds is equivalent to 1 minute. Next, I'm going to look at minutes and hours and find the relationship between them. I know that 60 minutes is equivalent to 1 hour. The next step has me going from hours to days, and I know that there are 24 hours in 1 day. When I'm writing this initially, it doesn't matter what unit I'm writing first. I'm just making sure that they are equal to one another. Then, days to years. In 1 year, I have 365 days. Again, it doesn't matter if I write 365 days equals 1 year or 1 year equals 365 days. All right, so now I have a plan. I know what pathway I'm going to take. The next step is to begin. When you start solving the problem, you are always going to start with the number that is given. So I am starting with 150 million seconds. I am always going to multiply every single step of the way. And I'm going to multiply by a series of fractions. So the first step tells me I need to get from seconds to minutes, and I know that these two values here are equivalent to one another. So that means when I write them as a fraction, one can go on the top and one can go on the bottom. In order to decide what goes where, I am going to make sure that my units cancel, not my numbers, but my units. If I have seconds on top, I need seconds on the bottom. So 60 seconds is going to go on the bottom this time, and 1 minute on the top. Again, the top and the bottom have to be equivalent to one another in terms of time. So now, if I stop the problem at this point, I would know how many minutes are in 150 million seconds. But I'm not going to pick up my calculator yet. I'm going to set this up as one long problem. So the next step tells me I need to go from minutes to hours. In order to get from minutes to hours, my unit conversion is given there. We always multiply, and we always multiply by a fraction. 60 minutes and 1 hour are equivalent amounts. One's going to go on the top and one is going to go on the bottom. In order to determine what goes on the bottom, I'm going to make sure that my units that appear in the numerator also appear in the denominator. Notice that seconds was on top and then on the bottom, so it cancels out. Minutes was on the top and on the bottom, so it cancels out as well. If I stop the problem right now, I would know how many hours are in 150 million seconds. Don't pick up your calculators. We're going to keep going all the way till the end. So now I'm going to go from hours to days. In order to go from hours to days, I know that 24 hours is equivalent to 1 day. So I am going to put 24 hours on the bottom, and I'm going to put 1 day on the top. My hours cancel out with my hours, and now I have the unit of days. All right, I'm almost there, just one more step. So in that last step, I need to go from days to years. 1 year is equal to 365 days, so one of those numbers can go on the top and one on the bottom. Again, the way I'm going to decide is to make sure that the unit appears in the numerator and the denominator so it cancels. Right now, the only unit that is remaining is days, and I need to get rid of that so that my final answer is in years. I'm going to put my days on the bottom, and the number that goes with the days is 365. 365 days is equivalent to 1 year. In putting it this way, my days cancel out. When the only unit remaining in the problem is the unit that the problem asked for, again, age and years, you know you're done. When you are done, at this point, you're going to pick up your calculator and you're going to put it in. Now, there's a bunch of correct ways to put it into your calculator, but if you know that you are not great with parenthesis usage, I would highly suggest that you multiply all the way across the top, which ends up being 150 million times 1 times 1 times 1 times 1, so 150 million. And then on the bottom, I'm going to multiply across the bottom. I'm going to take 60 times 60 times 24 times 365. And when I do that, I get 31,536,000. Now that I have the top and the bottom reduced, I'm simply going to divide the top by the bottom. And when I do that, I end up with 4.8. Now, the key is that we can't leave a number without a unit. We need to know what this number represents. So this 4.8 is going to have the unit of years, since it is the only unit above that did not cancel out. This tells me that 4.8 years is exactly equivalent to my original 150 million seconds. Even though this seems tedious at first, the more you practice this, the easier it gets. And we do have to do this. It doesn't matter where you are. This is our universal means of communicating in chemistry. So our setup needs to be the same. As far as what you need to show for your work, you don't have to show every single thing that I wrote down here. If it helps you, you can. But at a bare minimum, you need to show what I have here. All right, let's do a second problem. In the last problem, we saw that the 1 always ended up on the top, but that is not always the case, so you should not rely on that as a means of determining what goes where in your problem. So this example, we are starting with the moon, and we know that the moon is 238,900 miles away from Earth. I want to know how many inches this is. So again, I'm going to come up with a plan. When I come up with my plan, I'm going to identify my starting unit. I am starting with the unit of miles, and my end goal is to get to inches. I'm going to have to come up with a pathway in order to get from miles to inches, and I know I can get one step closer to inches by changing my miles into feet. Then I can change my feet into inches. I have to determine my unit conversions for this. Now, these conversions will typically be given to you if you are not familiar with them, but I know that there are 5,280 feet in 1 mile. And again, that is something that would typically be given or something that you could look up. Feet to inches, I know that there are 12 inches in 1 foot. So 12 inches equals 1 foot. All right, now that we've come up with a plan and we've found the equivalents to get from the beginning to the end, we're ready to start the problem. When we start the problem, we should always start with the number that is given, 238,000 miles. Make sure that you put your units on throughout the entire problem. Your starting number is always on the top, so it's in the numerator, so I like to put a line there so that I remember it belongs on the top of the fraction. If it bothers you, you can put a 1 underneath if you don't like leaving that bottom empty. Every dimensional analysis problem, every time we multiply. We are going to multiply by a series of fractions, and those fractions need to be equivalent amounts of distance this time on the top and the bottom. So, first step, I need to get from miles to feet. Since 5,280 feet equals 1 mile, one of these is going to go on the top and one of these is going to go on the bottom. Since I have miles in the numerator, I'm going to put miles on the bottom, and the number that goes with the miles is 1. 1 mile is equivalent to 5,280 feet. By putting the miles on the top and the bottom, they cancel out. So once again, my units are canceling out, but not my numbers. If I stop the problem right now, I would have feet. But I need to try and get from feet to inches, and the equivalent that I need is given right here. I'm going to make another multiplication sign, and on the top and bottom, I'm going to put the 12 inches and the 1 foot. In order to decide what goes where, I make sure that my units of feet which appear in the numerator here, are in the denominator so that they cancel out. 1 foot is equivalent to 12 inches. My units cancel out. When the only unit remaining in the problem is the unit that it asked for, you know you're done. So the only unit that hasn't canceled out here is inches, so I'm ready to solve. When we solve, we're going to multiply across the top. Now, remember that before we saw in the last problem that the top was always 1. That's not always the case. In fact, there won't always be 1s depending on your conversions. So 238,000 times 5,280 times 12. When I do that, I get 1.51 times 10 to the 10th power. Then I'm going to multiply across the bottom. When I multiply across the bottom, I just have 1 times 1, which gives me 1. Take my top divided by my bottom, so 1.51 times 10 to the 10th. Don't ever leave a number hanging without a unit. We need to know what this number represents. This number represents inches, and I know that because it's the only unit in the problem that did not cancel out. This number of inches is the exact same distance as my original 238,900 miles. If you are not familiar with scientific notation, watch my other video that'll go through scientific notation and a recap, how to write it and how to put it in your calculator. Thank you for watching, and don't forget to check out my other videos.